In this lesson, we'll lay the foundations for working with nested loops in Python. I'd like to stress the importance of having a solid understanding of this tool, since it can open a lot of doors for you as a programmer, analyst, or data scientist. Moreover, I believe the best way to study nested loops is through practice. To be able to do that, though, knowledge of using sequences, range objects, and iterations is essential. Fortunately, you are already well aware of these terms, so let's just get right to coding. To prep for nested loops, let's start from a simple for loop. In the first code cell, write for I in range, 2 in parentheses, colon, and then on a new line, print I in parentheses. As you can see, this is a very simple loop that will print the two numbers from the sequence generated by the range function. Then, in another code cell, write an identical for loop that will iterate over the sequence of numbers generated by a range function with a stop value of 5. Let j be the iterator variable of this iteration. As you execute this code, I am sure that the output containing the whole numbers from 0 to 4 is coming as no surprise, right? All right, now we get to the technique which is central to this lesson. Python allows us to have a loop within another loop. Let's copy the first loop we saw for I in range of 2, colon. And then, instead of writing the body of the loop, we can copy the second loop we saw. What we get is the loop with iterator variable j printed as many times as the loop variable I looped over it, so twice. Okay, to visualize this better, let's print a list with elements I and j at each iteration. As we execute this cell, we were given an output containing 10 elements. Let's dissect this program to better understand why we obtained such a result. To begin, the first two rows represent two loops that form a set of nested loops. Let's call them the I loop and the j loop for simplicity. Thus, the names will correspond to the letter we've used as a loop variable contained in each one of them. In addition, we want to point out that the j loop has been nested in the I loop. We can also say that it has been placed within the I loop or inside the I loop. That's why the j loop is called an inner loop, while the I loop an outer loop. Finally, on row 3, we have written a command that is referring to both of the nested loops. So, which and how many combinations of elements of the two sequences did this program display, and in what order? Here's an explanation of the relevant process occurring behind the scenes. During the first pass of the outer I loop, which is when we are on the value of 0 here, the inner j loop will be triggered, and then all its elements will be taken one by one until the sequence of numbers generated by the range of 5 ends. So far, this makes a total of 5 combinations, all of which have been represented as lists: 0 and 0, 0 and 1, 0 and 2, 0 and 3, and 0 and 4. Alternatively, if I represents the rows and j the columns in a table, then we can say we have exhausted all possible combinations between the element in our first row and the elements from every column. Great! After we've done this, we can move forward to the next step, which will be to combine the second element of the outer loop, I, or the second row, with every element of the inner loop, j, or every column. This means that the second pass of the loop will once more trigger our inner loop. That's why the remaining 5 combinations are 1 and 0, 1 and 1, 1 and 2, 1 and 3, 1 and 4. To sum up this process, you can say that for the values from every row, we'll extract or draw the value of every column until we've used the values from all columns. Moreover, this operation will continue until all our rows end, which, in other words, means that we will be out of values in our outer loop, that is, the I loop. All right, let's check out some more complicated examples. Note that these will not only serve to solidify your understanding of nested loops, they are also meant to show you a few variations you may decide to take advantage of while writing different programs. For instance, you don't necessarily have to iterate over sequences composed of numbers. String values can be used too. Therefore, here we can substitute range of 2 with a list containing the following text values: product A and product B. As we execute this cell, we obtain 10 combinations again, this time half of them starting with product A, and the other half with product B. Furthermore, When we are in professional environments, we may not always be required to use generated sequences as iterables in our nested loops. As you may have guessed, a neat way to write your nested loops would be to store the sequences in variables bearing meaningful names. For example, we can store a list containing the strings product A and product B in a variable called products. Just as we can have a variable with an abbreviated name for expected sales containing values for certain sales scenarios, supposedly in dollars. After we've done this, we can write a loop that for I in products and J in expected sales will print out the combination of each of their elements. Is it working properly? Yes, it is. Nice. Please feel free to revise what we talked about in this lecture if necessary. You can also take a little breath before the next video, where we will go one level up in complexity. Thank you for watching.